Hello, welcome back once again. We are continuing from our series of regression. I want to show you how to perform a simple linear regression, a multiple linear regression using GDP as our target variable and human capital here and total population as our independent variable. GDP as a dependent variable, human capital and total population as our independent variable. Therefore, we'll go straight to the question. Open it up. I've opened it as a group. These are the variables. We have GDP, we have human capital, we have total population. We want to see how human capital impact on GDP and how total population also impact on GDP. They have positive impact on GDP or negative impact on GDP. As we know all, in theory, human capital is increasing, GDP also increasing. That is, the upper expectation is that human capital has a positive impact on what? On GDP. Population is a controversial variable. In some clients, population should have a positive impact on GDP if other factors like human capital are moving fine. But in other words, in some population, like in developing countries, population has a negative impact on GDP. Population has a negative impact on GDP. Like in developed world, let's take for example China. Population is having a positive impact on their GDP, meaning that the more the population, the higher the GDP. But in developing countries, less developed countries, the more population, it has a negative impact on GDP. So population is a controversial variable. And let's go to drawing the multiple regression. Go to quick, go to estimate. This is the estimate dialog box. We have our GDP space half constant, human capital space what? Total population. And here we just select OLS least square estimate. Selected here. From 1980 to 2017, they are variable. Go ahead and click OK. As you can see, these are results. And forgive me to say, the variable, the result here, the model here is not significant. I have some values that show me that the variable is not significant. As you can see, our human capital has a negative impact on GDP. Total population is going with the sign, is correct, having negative impact on GDP. But the p-value, which is our main target in determining a good model, shows us that human capital here is not significant in explaining GDP. Likewise, total population is not significant in explaining GDP. Why did I say so? For a variable to be significant, the p-value must be less than 5%. I repeat, for a variable, which is these two variables, for any of them to be significant, their p-value, which is this, must be less than 5%. And from our analysis here, we can see that the p-value for human capital is 0.3, which is above 5%. Likewise, the p-value for total population is 0.674, which is above 5%. And moreover, we can see that the R square here, which is the determinant of how these two variables affect GDP, that is, the value R square show us how the variation in GDP that is caused by combination of human capital and total population, it's shown us that it's 4%, which significantly shows that the model has a problem. Likewise, we can see the F statistics, which is less than 1, and also the F probability value F statistics, the overall F statistic is above 5%. This also is a sign. However, the only sign I can see is positive here is just this the Wattis statistics. Hence, we say that this model is not a good model to perform our analysis with, because if we go with this model, it might be giving us a misleading result. It's giving us a misleading result because of these values. Actually, these values are very poor. However, the sign of population here is showing us that a 1% change in population result in 4% decrease in GDP. Meaning that if population increase by 1%, GDP will decrease by 4%. Likewise, the human capital index is showing us that if human capital increases by 1%, GDP will decrease by 13%. That is, if human capital decreases or increases by 1, let me start with if human capital increases by 1%, by 1 unit, GDP will decrease by 13%. Reverse is the case. If human capital decreases by 1%, GDP will increase by what? 13%. However, the variable is not significant in explaining the variation in GDP. Likewise, total population is not significant in explaining the variation in GDP. We can say that this model is not properly specified, or the variables have some underlying problem. We will continue in the next video